This is the third video of Module 2 on solving systems of linear equations by elimination. To perform elimination to solve a system of equations, we work to eliminate one of the variables by adding or subtracting the two equations together. So jumping right into an example, we'll examine how we can do this. We have two equations, which we can label as equation 1 and equation 2. And we want to look at the coefficients of each of the variables in both of the equations. And remember, the coefficients are the number in front of the variable. When there is no number in front of a variable, it's implied that the coefficient is a 1. And in order to eliminate one of the variables, we must have the coefficients in front of the variable must be the same or of opposite sign. In this case, we already have two coefficients that are the same. So the coefficient of x is the same in equation 1 as it is in equation 2. Now, if we subtract equation 1 from equation 2, we will eliminate the x variable. We take 1x and we subtract 1x, and what we get is no x's left, so 0x. Next, we take minus 2y and we subtract 1y, and we get minus 3y. On the right-hand side of the equation, we take positive 2 and we want to subtract 5, and we get negative 3. Solving for y now. So now what we've done is we've eliminated the x variable, and now we have one equation in terms of y. To solve for this equation, we divide both sides of the equation by negative 3, and we find that y is equal to positive 1. Now, to finish solving this equation, we can sub in the variable y with the value of 1 into either equation, and we'll find the x variable. So subbing it into the second equation, so sub y equals 1 into equation 2, we find that, so we have x plus y is equal to 5. We plug in 1 for y, and we find that x is equal to 4. Okay, the decision to use equation 2 was really just an arbitrary choice, mostly because that equation has smaller coefficients and is easier to work with. But if you sub it into either equation, you will get the same solution. So the solution to this system is 4, 1. And we've actually worked with this example already. In the previous video, we looked at verifying that it was a solution to the system, and we also have looked at solving this graphically. In this next system, we have another two equations, and you can see the coefficients of the variable x and the coefficients of variable y don't match. So what we need to do is either make the coefficients, the numbers in front of the x variables, the same, or the numbers in front of the y variables the same. And what we do is consider a multiple of equation 1 and equation 2 to make those coefficients equal. So looking at equation 1, we can multiply it by 2 to make the coefficients of the x variable the same. When we multiply equation 1 by 2, we multiply each and every single term in the equation by 2. It's not uncommon for students to forget to multiply the right-hand side of the equation by 2 and leave the right-hand side there as minus 4 instead of minus 8. Okay, now we're going to subtract the existing equation 2, and we do so. So we're subtracting, just a reminder there, because if you don't subtract, then you won't be able to eliminate one of the variables. And as long as you've done everything properly, then you will eliminate one of the variables. We end up with 2x minus 2x, so we have no x's. We have 4y minus 4y, which again we have 0y, and minus 8 subtract 8 gives us minus 16. Okay, this is a little bit different. So now we want to solve for y, but there is no value of y that will satisfy this equation. So there is no solution here. And this brings us back to what we did in the very first video when we looked at types of solutions. And you can see by looking at these two equations, and it's even best to examine them right from where we've made the coefficients equal, that these lines are parallel but not equal. So that means that we didn't even really have to proceed and perform elimination. We can see right away that there is no solution. Looking at the system in question 3, we can label the two equations. And again, our goal is to make the equations have two variables with equal coefficients. So the easiest way to get the coefficients to be equal in this case is to look at the coefficients of x, which are 2 and 1, and we can make them equal to one another by multiplying equation 2 by 2. So we want 2 times equation 2, which will make both of them equal to 2x. Again, make sure that you multiply each and every single term in equation 2 by 2 to express it as an equal equation, and we're going to subtract the equations from one another to solve, to eliminate x. So 2x minus 2x is 0x. 4y subtract 6y gives us minus 2y, and 8 minus 18 is negative 10. Now we have an equation in terms of one variable, and we can solve for y. Solve for y, we divide both sides of the equation by negative 2, and we find that y is equal to 5. Now, we sub that value into one of the original equations. You can sub y equals 5 into either equation, and you will get the same solution. It's always fun to actually test that theory out, and if you're working on this with a classmate or on your own, even just try both of them and make sure you get the same answer. So looking at equation 2, we have x plus 3y is equal to 9. Solve for x by bringing the 3y to the other side of the equation, and it becomes negative. And subbing our value of y in, we get 9 minus 15, which is equal to negative 6. Therefore, our solution is negative 6, 5. Now we're given two equations, and we're told to solve by elimination by eliminating variable x. So instead of having the choice of which variable we eliminate, we're told which one we're supposed to eliminate. If we look at the coefficients of variable x, the first one has a coefficient of 2, and the second has a coefficient of negative 3. Looking at the multiples of 2 and the multiples of 3, we have 2, 4, 6, 8, 10, and so on, 3, 6, 9, 12, and so on. And when we're considering what values to use, we want to make sure that we can make the coefficients equal, and so we want the lowest common multiple of each of the coefficients. And if we look through the list, the lowest common multiple is 6. So to get our coefficients equal to 6 or negative 6, we want to multiply equation 1 by 3 and multiply equation 2 by 2. Okay, now pause the video and multiply each equation by those numbers. You can see now that the coefficients of x are equal but opposite in sign. One is 6 and the other is negative 6. So in order to eliminate variable x, we're going to add both equations together. Add them together, you can see the x's cancel out, and we end up with 21y is equal to 63. To solve for y, we divide both sides of the equation by 21. We find that y is equal to 3. Now we sub the value of y into either of the original equations to solve for x. When we do so, we replace the value of y with the value of 3 and then solve the equation for x. When we solved for x, we found that x is equal to 2, and therefore the full solution to the system of equations is 2, 3. In practice question 2, we're going to solve by elimination by eliminating for variable y. So labeling our equations as 1 and 2 and looking at the coefficients of y. One of the coefficients is currently 2 and the other one is 5. And considering the multiples of each of those coefficients, we want to look for the lowest common multiple. And we see that the lowest common multiple of these two is 10. So we're aiming to make the coefficient of y equal to 10 in both cases. To do so, we're going to multiply equation 1 by 5 and multiply equation 2 by 2. So now our coefficients of y are equal to one another, and to eliminate variable y, we need to subtract the two equations. So we end up getting minus x is equal to positive 4. And when we solve for x, we find that x is equal to negative 4. And looking at this value, now we sub it into either of the original equations and we can solve for the value of y. And we found the solution to be negative 4, 10. And this is the same problem that we graphed in the very first video that we found to be very tricky to accurately graph to determine the solution to the system of linear equations. But what's really amazing about solving it algebraically with elimination is that you can solve for the value exactly where there is no bearing on the accuracy of your graphing, so your graphing skills. In question 3, we want to solve by elimination, labeling our equations as equation 1 and equation 2. We can make the coefficients of x equal to one another if we multiply equation 1 through by 3 and just look at equation 2. After multiplying through both equations, we can see the left-hand side of the equations, of both equations, are equal, but the right-hand sides are not. Therefore, these lines are parallel but not equal. Therefore, there is no solution. I like this practice example because we're asked to solve by elimination, but our variables are not listed in the same order. So before we can proceed, we must make sure that we reorder the variables. So we're gonna, it doesn't matter if you list x first or y first, I'm gonna go alphabetical. So you'll get 2x plus y is equal to positive 7. And in the second equation, you will have positive 6x when we bring the negative 6x to the other side, plus 3y is equal to 21, and that's equation 2. Okay, in order to solve by elimination, we're going to multiply the first equation by 3, which will make both the coefficients of x equal to 2. So 3 times equation 1, and then looking just at equation 2. After multiplying through by 3 for every term in equation 1, we see that both the equations are now equal to one another. Therefore, they're actually the same lines. And if we were to eliminate one of the variables, you will get that 0x or 0y is equal to 0, which is true for all values of y. Therefore, there are infinite number of solutions. Okay, that's the end of video 2. Now in the next video, we will be solving systems of linear equations using substitution.